So I'm super excited to be here again to talk with you about Swift, and I'm a little bit sick, so forgive me if I have to drink my magic potion to heal me. I don't know how many of you have been here back in October when I was here talking about clarity in Swift, and I was sharing some ideas about how to write nice, clear, understandable code in Swift. And so this is sort of a spiritual successor to the previous talk, because here's the thing. I used to believe that static typing, that statically typed languages, are all like a bad thing, you know, that it's just more work for me, but like I don't care, I don't see any benefits from it. I just didn't get it, right? Using Objective-C, I didn't see it. And coming from a background of Ruby and JavaScript, I just didn't see the point. I thought it just more work. But Swift proved me wrong. Swift showed me that that modern static typing, modern rich type systems are actually really nice, and you can actually take advantage of them in designing really nice, really clear, easy to use APIs in Swift. So I wanted to share with you those ideas through a case study using NS user defaults. So for those of you who are not iOS programmers, NS user defaults is essentially a persistent key value store. So you store things like in a dictionary, but it's persistent. So people use it for things like preferences, stuff like that, right? So here is how the API of NS user defaults looks like. So this is in Swift, but this is very much a Objective-C-like API. So the way you use it is first you have to get the singleton object through nsuserdefaults.standarduserdefaults, and then you have a number of getter and setter methods like string for key, integer for key, etc., and set object for key, set integer for key, and the like. Okay, so I first was looking at this API thinking how I can Swiftify it. Apologize, I am sick. Over a year ago. And so like the first thing I wanted to do is, okay, I just hate writing NS user defaults, that's standard user defaults. If I'm going to use a singleton, let me just have a better shortcut for it. But whatever, doesn't matter. But what really frustrated me about NS user defaults is that it really is like a dictionary. It has the semantics of a dictionary, right? It's a key value store. You put stuff in under a key and you fetch using a key. But it has a completely different syntax, right? You can't take advantage of this nice, familiar square bracket syntax, both in defining your defaults and in fetching and setting to the user defaults. So I thought, okay, what if we could have that in Swift? So that was my first shot at the problem. And I thought, okay, let me just extend NS user defaults and add a subscript. And a subscript is just a Swift name for the square bracket syntax. And the cool thing about the subscript is that it has two parts. It has a getter and a setter. So the square brackets and the square brackets equals parts of the subscript, right? So I just define a subscript that returns object for key, sets object for key, and then I could do this, right? Default subscript color. And I thought, okay, this is cool. Like it's shorter, it's nicer, whatever, cool. The only problem is that it would return any object or nil, which is to be expected, but like in a statically typed language, like I can't do anything with it. I have to cast it to some concrete type I actually want to use. So this is not so neat anymore. And I had an idea, maybe not such a clever idea, but whatever, I wanted to try it. That I would just have a subscript that returns a proxy object, right? And it will be an object that only like represents the actual key in the user defaults. And you have a bunch of properties as accessors, like string, int, and then you could do this, which is essentially equivalent to doing as question mark string or as question mark int, but I just thought it's nicer because then you don't have to, if you want to chain it, you don't have to put parentheses around it and whatever, right? And so you would have that, but if you want to set it, you don't have to say anything because you're taking stuff from the statically typed world, so you can just have a setter-only subscript that takes anything, right? So that was that, and I thought, okay, that's cool. What are maybe some common use cases for NS user defaults I can optimize around and maybe make better? So I noticed that, for example, I or other people would often use NS user defaults to store like counters of some sort that you would just want to increment. And despite the improvements I thought I've made, it's still kind of a pain because I have to get it and cast it the right value and add one and set it, and I thought, wouldn't it be nice if I could just do this, right? If it actually was a dictionary, if it didn't just pretend to be a dictionary, I could do that. So why can't I? And I thought, oh, why not? In Swift, operators are just functions, and I can overload them, so I can make my own plus equals that takes a proxy on left-hand side and integer on the right. Does the right thing for me, right? And then I could abstract one step further, add a postfix++ that adds one. And now I have this, which I really liked. And not just because it's short and neat and cool, but also because it's familiar, you know? You don't have to read too much into it. You don't have to think about it. It's easy to figure out what it does. Because when you see the square bracket syntax, you know what square brackets does. You know that this is some sort of a data structure, right? That it acts like a dictionary. And when you see plus plus, you don't have to follow the flow of code to figure out you're adding one. You just see, oh, plus plus, I know what plus plus is. So it's familiar, right? You can see it, and you don't have to follow through it to see that, oh, I'm just incrementing some sort of a counter in some sort of a data structure. And okay, so this isn't just like a random example. It was something I actually did over a year ago, an actual library, right? So the initial results would be like, okay, you have this shortcut, you have this convenient square bracket syntax, you have these helper accessors, you can set stuff using the subscript syntax, and you have these plus plus and plus equals operators you can use. So that was great, and then I used it in a few of my actual real projects, and I've been learning Swift and just using Swift more and appreciating more of what Swift is. I started asking difficult questions like, is it really Swifty, right? I thought I made a great improvement over the original API, and I still like it, right? But I realized that this isn't actually Swifty. What I did is just I put a fresh coat of paint that is inspired by Swift syntax and by Ruby a little bit, but it's fundamentally still an Objective-C-like mechanism. Because, for example, I started seeing these little potential problems that I don't know if they're important, but they just didn't seem like something like would happen in Swift normally. So, for example, if you would have a user default, right, that you would set somewhere, and then in some other place of the app you would want to fetch it, but you would make a typo in the key name and spell it mistakenly with a U, you would get a nil, right? You would have a bug. And okay, whatever. Like if you make a typo in a variable name in Swift, it will be caught by the compiler. So maybe it would be great if I could have that. And also, why do I have to type .string? This is kind of stupid. And also, it's another example. Two of the types supported by NS user defaults are NSDate and NSData. And they're spelled like almost the same, so I always would mess them up in my mind. So I would assign an NS date, a point in time, but then I would try to fetch NS data and I would get nil, right? Or if I try to do the thing the other way around, also a bug. Okay. And what about those operators I added? I thought I was doing something neat. I was like improving the programmer's experience because they can use plus equals, right? And this is great. But what I was also doing is I was kind of discovering the edges, the limitations of the approach I took in implementing them. Because the compiler, and I have no way of knowing if you actually wanted to store an integer or a floating point. So if you did have a floating point, but wanted to do plus equals 10, not 10.0, because you pass an integer on the right-hand side, I would have to assume it's an integer, right? But it would be a bug to do so because you'll cut off the fractional part. This isn't good. And some of this is kind of stupid, right? Like, okay, make a typo, something like that. You'll catch it quickly, right? You'll probably just run the app, see the problem. Oh, okay, I made a mistake, fix it, and that's it, right? But the thing is, it happens all the time, right? Those are the same kinds of bugs as making a typo in a variable name or a function name that you're referencing, or if you try to pass something of the wrong type to a function. It happens all the time. And it might not be a big deal because you'll usually discover the bug and fix it quite quickly. But when you actually start working with a language like Swift, which is compiled and statically typed and has tight integration with an IDE like Xcode, then you quickly grow to appreciate that you get instant feedback from the compiler. I didn't have to compile it and run it and get to the right place in the app, or run my tests, or discover some edge case. I can, the editor will just show me, hey, this cannot possibly be correct code. So it will catch the bug immediately, right? And I also realized with time, as I was using Swift as a statically typed language for a longer time, I realized that the benefits of compile time checks are not just for the you now, they're also about protecting the future yourself from your current self, right? Or the other way around, I always mess that up. Like, if you don't have these compile time checks, when in the future you change something, and hopefully your project will live long enough that you will change things, you will refactor your code, that causes lots of bugs, right? And some of it is inevitable. Like some of the time you'll make some structural mistakes and you have to go through the hard route to discover it and fix it. But a lot of the time, I find the kinds of bugs, most of the bugs you do during refactoring are those stupid kinds of mistakes that can be easily, quickly, immediately caught by the compiler. And again, you don't have to even spend 5 minutes to discover and fix it. You will, like, your Xcode or your whatever editor will just hand it your bugs like right onto your plate. And hey, these are 10 places that make your program incorrect. And that's sort of the power of static typing, right? And I saw that if you give the compiler what it needs, if you give it tools to help you, then it can help you, it can assist you, it can give you benefits in return. And I thought, well, why not take my library and see if I can actually make it more Swifty, more statically typed, and have it be beneficial to me, right? So one thing I noticed is that people, instead of passing string literals for things like dictionary keys or user default keys, sometimes people would assign them to a constant. Because then, like again, first of all, refactoring, if you want to change it, you only have to change it in one place, and you have a guarantee that it will only be in one place. And you can make a typo, because if you make a typo, it's a symbol, right? It's not just a string, so the compiler won't let you make that typo. So what if I could do that with my library, but also sort of embed type information about the value of the user default I want to represent? So I figured this out. So if I make a class that just wraps around a string, the key of my user default, but add a type parameter, the value type, right? And it's not actually a generic class, it's just a phantom type. It's just there, it doesn't do anything, right? But what it allows me to do is to create this. I can now define ahead of time a defaults key that represents a string and exists under a key of color, right? Or I could make a defaults key of int for launch count. And then what's great about it is that then I can make a subscript that takes defaults key of string returning a string. And then I would return string for key and set object for key. And now if I do that, like first of all, there's no way I'm going to make a typo because it's only defined once. I say once what I want and then I reference the symbol. So it is compile time checked. But then if I want to set some value, I cannot possibly assign a value of the wrong type because the compiler just won't let it. If you're accessing a defaults key that's a string, it can only accept a string. And when you fetch from user defaults, you don't have to type .string or as_string or any of that stuff. It will just be string always, all the time. You only pay the price of defining your type once, and then you get all of those things, all of this safety and these slight conveniences for free. Isn't this interesting? And another thing, so this is quite Swift specific, so I apologize if you're not a Swift programmer, but this is really cool. Swift subscripts are just awesome. Their semantics are just great. So before I added this +=1, or += and ++ operators for my user defaults proxy object. And I had to do it because, well, you can't += on a copy of an in, like it just makes no sense, right? And it happened because like I had two different subscripts. I had a getter-only subscript that returned this proxy object, and a setter-only subscript that took anything. But here's an interesting thing. If you try to do the same thing with a Swift array, just say you have an array of 1, 2, and 3, and you want to modify, say, the first element of this array via the subscript, it will work. And like the first reaction is, of course, it will work. Like this is what you expect. But then you think about the semantics, the value semantics of integers in Swift, and it makes you curious, or it made me curious for sure. Like, how does it work? Like, how can you += something that just returned as a transient copy, right? Like, integers have no references. They're not objects. They're values. They're always passed by copy. So, But it works because a proper subscript has two parts. Again, it has a getter and a setter, right? And before, because I wanted this proxy thing, I had two different subscripts, one for the getter, one for the setter. They were different things, but because I did the defaults key thing, I could make just one that has both a getter and a setter. And here's the magic thing. Because of that, when you do array subscript 0 += 10, the compiler can, for you behind the scenes, without you having to think about it, do what's actually required, which is get the value using the subscript, modify the copy, the value returned, and set the new value. Okay? And it can do it because you're using one subscript, but because it's not a method, but it's a subscript, it has a getter and a setter, it can do this. And before, like in my original Swiftification of an user default, I didn't get that. I only used a subscript because it was familiar, only because of its syntax, but not because of its semantics. I missed out on this completely. But now I don't need a custom += or a ++ or anything like that. It just all works out of the box for free. And I can modify numbers. I can append to arrays. I can change strings. And all of this, even though this isn't in memory, like it's a persistent data structure somewhere on the disk, but I don't have to think about it. It just works. So this is cool. One thing that was cool though about the Statically-Typed approach or at least arguably cool, is that like you didn't have to define your default keys ahead of time. You could just pass a string in line, right? And now, if you have to define them, you probably want them in some one centralized place, maybe put them in some global or in a structure, or maybe put that structure in your class. But it's a tiny bit more typing, and it's not a big deal. But I thought, whoa, okay, can I make it even nicer, just for me as a programmer? And here's another thing that's also very Swift specific, but just shows the power possible with modern static typing, with modern type systems. It's called implicit member expressions, and it works like this. So you have an enum, like left, right, up, down, right? Have a function that takes a direction. So you can pass as an argument direction.left, referencing one of the cases of the enum. But you can just say .left in Swift. Just as if you were like in Ruby, you would pass colon left, or the string left in JavaScript you would probably do. But this is still statically typed. The compiler will still check that you're passing one of the possible values. But because the compiler knows that the turn function takes a direction, you don't have to say it's a direction, because the compiler already knows it, right? So you don't have to pay the price of this static typing multiple times. The compiler can infer things for you. So I thought, okay, if I have a subscript that takes a default key, if I had a default key.color, then I could just say .color. And it's a bit tricky in the actual implementation because of Swift's compiler limitations, but I won't get into it. But long story short, it is possible, and it is great, because you can actually do this. You can just define your key in one place, sort of globally for your app if you want to, and then you can say default subscript.color, right? And you get all of the benefits. You can make a typo. Everything will be type checked. It's safe. It's better for refactoring. But it's not much. It's not more work, right? It's like the same, and you get those benefits. So this is interesting. Also, another cool thing about types is, see, in user defaults, if you want to fetch a string, but it's not there, you'll get a nil, right? Or an integer is not there, you want to get a nil. But sometimes you don't care about the nil, you don't want to deal with the nil, you just want a reasonable default value, like a nil value. So you want to get a 0, or an empty string, or an empty array, that kind of thing, or a false. And with my library, like the cool thing about using the actual types to describe the structure of your user defaults is that you can use the actual types to describe the semantic, right? If you want nils, you say int question mark, which means int or nil in Swift. If you want a 0, you just say int, right? Or another cool thing is that I could easily, without like any special syntax, again with the same syntax, without anything special, I could add support for typed arrays. So instead of storing an array of any object in the user defaults, you can store an array of strings. And the great thing about it is that, again, if you append two things to that array through the user default subscript, it will be type checked. You can't append to a string, to an array of strings with an integer, right? And when you fetch from it, when you subscript the array, again, it will be typed as string for free. Or I could add support for, like seamless support for custom types. So for example, and user defaults only supports a handful of standard types like strings, numbers, array, that sort of thing. But if you want something custom like NSColor, you have to serialize it, right? You have to turn it to NSData and then from data back to NSColor. But because we have this standard serialization protocol, NSCoding, I can just take advantage of it so that I'd have to do almost anything to get this. So if I define a default key of NSColor, I can just use NSColor, right? I can check it if it's nil, I can set new values, I can chain right into this NSColor's properties, and it all just works. Even though it's a persistent structure, it has to be serialized, but I don't have to see it as a user of this API. So again, this is an actual library. It's called Swift User Defaults. You'll find it on GitHub if you want. So again, if you want to, you can store all your keys in one place. You define them once as defaults key, pass the type of the value into store, then on the key. You have this default shortcut. You have the subscript syntax, the dot shortcut syntax for referencing those keys. You can set things. When you fetch things, they're typed. You have all of the power of value types and arrays, also typed arrays, and even custom objects. And that, I think, is cool. And the great thing about it, like, what's actually the point? What I discovered is that, hey, static typing actually doesn't hurt. Not in Swift, anyway. Like, I didn't have to force myself and push myself to do all this extra work to get the benefits, to get the compile time checks, right? Like, my life is not worse because of that. It's better, right? It didn't hurt to actually embrace the type system. And the way I see it now is it's a deal, right? You have to pay the price to opt in. You have to give the compiler what it wants. And with my library, you have to define this, your default keys ahead of time. With Swift in general, for example, when you define classes or you define functions, you have to they have to be explicit about their types, right? So if you define a function, its signatures has to say what types of arguments it takes and what it returns. But then when you do that, when you invest a little bit, you get much more, I feel like, from the compiler back, right? You get compile time checks, which means fast feedback, which means entire classes of just stupid things. You don't have to even run, recompile, like browse throughout your app to discover. You'll discover it immediately, and you will fix it immediately. And it means greater degree of confidence when you refactor. It means auto-completion. So if you work with JavaScript, for example, or Ruby, the text editor can pretend it has auto-completion by scanning for symbols in the file you're working on, but it can't really do a good job of it. But when your Xcode, for example, knows the entire structure of your code and knows the types of everything, it can, like, as you're typing, you say like variable name dot, and it already shows you all of your possibilities. And this is great, right? I have to do a little bit more typing up front, but then I have to do less typing manually afterwards. This is nice. Inferred types. So same deal. You pay the price once in the signatures of your functions or your default keys or your whatever. But then you don't have to cast it again. You don't have to, in your method bodies, in the bulk of your code, you don't generally have to define the type of your variable because it's going to be inferred from what you assign to it, right? And because I embraced the type system, I got something that plays nicely with value types, which is kind of a big deal in Swift. And so my conclusion is, hey, truly Swifty APIs use static typing, and they embrace the type system. And you know, if your view of a compiled statically typed language is shaped by something like Objective-C, then you have to give it another shot, right? It's like modern type systems are actually nice, and sure, you have to invest a little bit of your time to, like, there's a learning curve, right? You have to learn how to use it, how to take advantage of it. But once you do, you'll find that the vast majority of the time, it's actually the approach that makes most sense and is actually really nice and really great to work with. Thanks.
Thank you for your presentation. It was really nice approach to making your code more Swifty.
Thanks.
There was one thing that wasn't natural for me, not something I didn't expect, is that when you call append on something that is returned,
yeah,
is it like you didn't have to do anything additional work to make it use save from subscript, set on subscript? because it doesn't feel natural. Like the array is returned, and then you append to that, and you don't care about results.
Yeah. This is exactly how it works, and if you do it with an array or a dictionary, that's exactly how it's going to work. If you like chain through using a subscript to modify a value type, you will modify it. But the thing is that it will only work if your array or your dictionary is defined as a variable, not with a let. So that's why the default shortcut, the global singleton object, even though it's not meant to be changed, like you're not meant to assign a new value to it, it's defined with a var, because then you can do the chaining through the subscript to modify data that's in the user defaults. Make sense?
Okay. Yeah.
Right. But of course, like if you don't do it like via chaining, but you assign it to a new variable, like then you get a copy. So like there's no like.
That's how I would do it.
Right. More questions? All right. Cool. Thanks.